Welcome everyone to this section on conditional expressions and operators. In this section of the course, we're going to be focusing on being able to conduct logical operations and functionality within our SQL code. We'll be learning about keywords such as case, coalesce, NULLIF, and cast. Then we'll also learn about some additional functionality which allows us to expand on the usefulness of PgAdmin, things such as creating views as well as import and export functionality. So as I mentioned, we're going to be able to add logic to our commands and workflows in SQL. Let's get started. I'll see you at the next lecture. Welcome back everyone to this lecture on the case statement. We can use the case statement to only execute SQL code when certain conditions are met. This is very similar to if-else statements you can find in other programming languages such as C++, JavaScript, Python, etc. Now there are two main ways to use a case statement, and that is to use a general case statement or a case expression. Now keep in mind, in many situations, both methods can actually retrieve and lead to the same results. So I want to first show you the syntax for a general case statement. Here's the syntax for the general case. And the way it works is at the very beginning, we have this little block of code that we're going to start off with the case keyword. And then we have when and then keywords. So we start off by saying case, and then when a certain condition is met, then have some sort of result returned. And then if we want to check against another condition, we can keep listing them. So when condition 2 occurs, then return result 2. And finally, at the end, we can have an else statement, which basically says if none of the above conditions are met, then return some final other result. And then we can end that. So let's go ahead and see an actual example of this so it's a little more clear. Let's imagine that we have a very, very simple table. And in fact, this table is just the table here I've seen on the bottom, where there's a column called A, and there's two entries in this table or column, entry 1 and entry 2. So this is our test table, and if I say select everything from the test table, this is what shows up. Now let me show you what it looks like if we want to use a general case statement. So I will say select the A column, comma, case, and then I can do the following. I can say case when A is equal to 1, then string 1. So what that is saying is if the instance in column A for that row happens to be equal to 1, then go ahead and return the string 1. And let's check for other cases or conditions. When A is equal to 2, then return the result string 2. Else, if it's not 1 or if it's not 2, return other. And then I say end, and then from whatever table I want. So the way this works is we're basically inserting this general case statement inside of this select call, almost as if it was another column. So notice here I'm saying select A, comma, and then I have this case statement inserted, which is basically going to return the results based off those conditions as another column. So the column is by default called case, but you can always use an alias to name it something else. So you could say something like case when A is equal to 1, then 1, when A is equal to 2, then 2, else other as label, and then that's going to relabel that returned column. So basically the way I like to think about this is for the general case, you're just essentially substituting calling a column that already exists with your own general case statement that is going to return certain results based off certain conditions within another column. And then you just end the case, letting SQL know that you're going to continue on with the rest of your query, such as doing something like from test. And if you want, you can add things like order by after that. So the way I like to think about this is the general case is kind of this giant substitute for a column call where you can define your own conditional logic as far as what you want returned. Now that was the general case statement. Let's explore the case expression syntax. And this is sometimes confusing to beginners because it looks very similar to the general case statement. The main difference is that the case expression syntax first evaluates an expression and then compares the result with each value in the when clauses sequentially. So this is the case expression syntax, and the difference is pretty subtle, but you'll see here that right in front of the case, we're actually going to evaluate an expression. And then the when statements, instead of having actual conditions within them, they're just going to have values. So they're basically checking for when this expression is equal to value 1, then return result 1. The case where this expression is equal to value 2, then return result 2. Else return some other result, and then end that case expression. So let's go ahead and rewrite our previous example. So the way this works is, notice here, I no longer have to actually have that condition after the when. With the case expression syntax, I'm now saying case A, so that's my expression, just the column itself, when it's equal to 1, then 1. When it's equal to 2, then 2, else other. So this is basically saving you the step of having to check those conditions yourself manually. You can think of the case expression as something to use when you're just going to do a bunch of checks for something being equal or equality. The general case syntax that we saw earlier, let me go back to it here, we can see this is actually going to be more flexible because the case expression syntax essentially just checks for equal or equality to the provided expression, which can be as simple as a single column provided. The general case syntax allows us to do all kinds of conditional checks. So we can do things like when A is in between the values of 5 and 10, or when A is greater than 4, etc. So case for the general syntax allows us to do a bunch of conditions individually and uniquely right after those when calls. The case expression syntax is essentially just evaluating one expression, and then you're listing the possible values to be equal to that expression. And often that expression is just a simple column call, such as case A, when 1, then 1, when 2, then 2, and so on. Okay, so those are very simple examples, but let's go ahead and look at some more realistic examples through PgAdmin. I'm going to open up PgAdmin now. Okay, here I am inside PgAdmin. I'm going to go ahead and just explore the customer table. So let's grab everything from customer, run that, and I see I have a customer ID, store ID, first name, and so on. Let's go ahead and work under the assumption that the customer IDs are assigned as serial primary keys. So what I mean by that is if your customer ID is 1, then you were the first customer to ever purchase something at our store or rent something from our DVD space. And if you're customer number 2, then you were the second customer, and so on. So let's go ahead and run a promotion for maybe our different tiers of customers. Let's go ahead and set customers that are in the first 100 to be kind of a premium status, and then customers between 100 and 200 to be a plus status, and then everyone else just to be a normal customer. So this is a great situation for the case. So I'm going to select customer ID from customer and run that. And so now we're essentially kind of simplifying this down so it matches more or less what we were doing in our calls earlier in the slides. Note here, it's actually not in order by exactly because 524 for some reason is just returned faster than everything else. So let's go ahead and make those categories with a case statement. So what I like to do is I set up my normal query here, and then I'm going to pretend this is another column call. So I will say comma, and then this is where I'm going to insert my case statement. And it's really quite common to use spacing and indentation to help organize your case statement. Although keep in mind that SQL itself doesn't really care about your spacing or indentation that much, as long as your keywords aren't touching each other essentially. Okay, so here's our case statement. So I'm going to say case, and then let's go ahead and write in our corresponding end. So now that we have that kind of done, I'm going to use the general syntax, which means I'm going to have my when calls. So here I'm going to say when, And let's go ahead and first check for when the customer IDs are less than or equal to 100. Going to put these inside parentheses. So when the customer ID is less than or equal to 100, then, and I have to decide what to return when the actual case happens to be that the customer ID is less than or equal to 100. So let's label these our premium customers, since we want to reward them for being within the first 100 customers. And now let's go ahead and have another condition to check against. Note here I don't put a comma between my conditions. So now I'm going to say when. Let's go ahead and type out when customer ID, and now let's do everyone that's between 100 and 200. So I will say between 100 and 200. Then let's call these customers plus. So note here, basically all I'm doing with this general case statement is after the when keyword, I have some sort of condition, and I have a lot of flexibility over these sort of conditions, and then I have to decide what do I return if this condition happens to be true. And then you can keep listing when, then lines or clauses for as many conditions as you want to check. Then the last thing we're going to add in after you've decided you've checked all your when conditions is an else statement. And the else statement basically says, hey, if you're not true for any of these conditions, meaning I didn't return a premium and I didn't return a plus, then what should I return? So go ahead and check for those conditions. Else, if none of them happen to be true, go ahead and return something. So let's go ahead and say that will be the string normal. So let's go ahead and run this, make sure we have no typos. And I'm going to zoom out just a little bit so we can see this here. But note that I have my premium customers. We can expand this column. So all my premium customers, and if I keep scrolling down beyond 100, then I have my plus customers. And then if I scroll down beyond that, I should be able to see my normal customers over here beyond 200. Okay, so again, the syntax for a general case statement is you basically plug it in lieu of a column here, and then you have your when keyword, the condition you want to check, then what should you return when that condition happens to be true. It doesn't have to be a string, it could have been a number or a digit, etc. Okay, so last thing I want to point out is you often want to actually call this something. Note here it just returns the column name as case. After the end statement, I can use an alias saying something like as, and I could say like as customer class, so what class this customer's in. And I run that and I'll rename the column for me. Okay, so we can see here that the general case statement is the one that's the most flexible because you can check all kinds of conditions. But often for case statements, you're just going to be checking for equality. So the simpler version of that is that case expression, where right at the top, you're going to check for a case expression and then just check for equality off of that. So let's imagine that we are running a raffle. So let's go ahead and just come back to select customer ID from customer, run that, and whoops, make sure we delete that comma here, run that. So here's my customer ID, and I'm just selecting a customer ID from customer. And now what I'm going to do is I'm going to hold a raffle. And let's say I held the raffle separately, just kind of some random lotto tickets, and I'm going to pick based off the customer ID number. So based off kind of my random choice, I decided number 2 is the winner, customer ID number 5 is second place, and everyone else is just normal. They didn't win anything. So how can I do this with a case expression? The case expression is probably the better choice here because I'm just going to check for equality. I'm just checking that if the customer ID is equal to 2, then I want them labeled as a winner. If the customer ID is labeled, let's say 5, that will be the second place in our raffle. Everyone else is going to be just labeled as normal. Since I'm just checking for equality here and not checking for things like between two values, then a customer expression is, or excuse me, a case expression is probably the best case for this customer ID check. So the way this works is same as before. I'll say case and then I will say end, except now right after my case, I'm going to provide my expression. And the expression here is just a simple column call, which is the customer ID. So I'm just going to check for the customer ID being equal to something. So note here again, my comma And this case end block is essentially the substitute for another column call. So I'm saying case where the customer ID, and then I'm going to say when, and I no longer need to say something like customer ID equal to 2. I can just type in 2. So this is nice, and this is just going to check for equality against this expression. So let's say when the customer ID is 2, then that's the person that won the raffle. We'll say winner. And now I can have another case. So let's say when customer ID 5, let's go ahead and have that person be second place. And then finally, everyone else, we'll just list them as normal. And I'm going to call this right after end as raffle results. So again, note the difference here is that I have this expression, often just a single column call, and instead of checking for conditions within the when, I'm just checking for equality. So it's checking when customer ID, when it's 2. Customer ID, when it's 5. So obviously this one is not as flexible as the general case statement, but it's kind of faster to type out. Basically saves you from having to type out customer ID equal to this, customer ID equal to that. Instead you just write customer ID one time, and then you just check for equality with the values themselves. Let's go ahead and run this, make sure we didn't commit any typos, and it looks like we're good. So let's expand on the results. And note here that it looks like customer number 2, the raffle results is this person is a winner, and customer ID number 5, this person got second place. Okay, awesome. Now the last thing I want to show you is you can actually begin to then perform operations on the results of these case statements. So let's take a look at our film table. I'm going to say select everything from film, run that. So we have our film ID, title, etc. And if we take a look at this, we have the actual rental rate. So we know there's different rental rates. Let's go ahead and make some categories for rental rates. And then let's also figure out how many we have per category. Keep in mind, technically, I could do this through some sort of group by call, but this is really to drive home the point that you can take these complicated case syntax statements and then perform operations such as a sum on them. I kind of want to walk through a little bit of logic here that may serve you well in the future, but keep in mind that you could have figured out this in other ways. So you don't need to write back saying, could we have done this with a group by? You probably could have if you were creative enough. So let me show you what I'm talking about first. So we're going to say select the rental rate from film, since that's kind of all I'm interested in. So I have these different rental rates, and I have a 99 cents rental rate. I want to figure out how many of these do I actually have. So let's go ahead and start categorizing things. We're going to say select, and I'm going to do the following. We're actually just going to say select, case, and now we're going to check for the rental rates when it's 99 cents, then label it or return 1, else 0. And then we have to have that end call associated with the case. So note what I'm doing here. I'm basically just saying select case rental rate. If it's 99 cents, then return a 1 in this new column, else return a 0, end this. So when I run this, I have this nice little case here. So case integer, bunch of zeros, and notice here it happens to be 1 if that rental rate was then 99 cents. And to kind of drive this point further, I could actually ask for the original rental rate column, comma, run that, and I can see the direct results next to each other. So nothing too crazy right now. It's essentially the exact same thing we did before, except we're returning 0 if it's not 99 cents and a 1 if it is. So now what I can do is I can actually take the sum of this case column to figure out exactly how many 99 cents movies I have. So the way I would do that is just as if this was any other normal column, I'm going to take this whole thing and pass it into sum. And then I'm going to delete rental rate since it doesn't make sense to call rental rate anymore, since I'm just taking the sum of this. and then I'm going to say as, let's say, number of bargains. So I'm going to say 99-cent films are a bargain. So if I take the sum of this return column in the case, then it's going to give me a 1 for every time there's a 99 cents, essentially counting how many 99-cent movies I have. So we run this, and we get back that the number of bargains I have, or number of 99-cent movies I have, are 341. So you're probably thinking right now, well, this isn't super useful because I could have already done this with things I know about group by and count and where and having and all these other tools that we've learned so far. But what if I want to now do this for different categories, such as bargains and regular prices? So I can keep doing this as if there were more columns. So after this, let's go ahead and just call this bargains. So these are my bargain movies. I'm also going to take the sum of, let's say, movies when they're $2.99. So let's say sum case rental rate when $2.99, then 1, else 0, and then finally end. So basically the exact same thing I did up here, except now I'm checking for $2.99. And let's go ahead and call these, let's say, as regular. So what's going to be pretty nice about this, and note here my comma because I'm basically treating this whole sum as another column call, that when I run this, I now am able to format the results in this easy to read manner where I have the number of bargains being showed at the exact same time of the number of $2.99 films. And so I can keep doing this for the other cases. Go ahead and copy this again. Add in a comma. I'm just going to copy and paste here the exact same code, except now I'm going to check for when it's $4.99. And let's go ahead and call these our premium movies because they're more expensive. And now I'm going to run this. And now at the exact same time as separate columns, I can see bargains, regular, and premium. So this is something that is a lot more difficult to do given the other tools we know. And it's almost impossible to format it in this way where each of these counts has its own column and its own labeled column. So number of bargains, number of regular movies, and then number of so-called premium movies. So this is really nice, and it allows me again to call functions on the results of a case column. And it's super common to use case with a when statement, and then you say then 1, else 0, as ways of summing things up or counting the results. Okay, so that's it for this particular lecture on the case syntax. Coming up next, we're going to have a challenge for you to make sure you fully understood what we went over here. Thanks, and I'll see you at that challenge lecture. Welcome everyone to your challenge task for case. So for this challenge task, we want to know and compare the various amounts of films we have per moving rating. So we want you to use case and the DVD rental database to recreate the following table. So this is showing me a count of the different ratings I have, particularly for just 3 rating types. That is an R rating, a PG rating, and a PG-13 rating. So go ahead and use the case syntax in order to recreate this table. So coming up are some hints. So the hint is to just really review our case expression example that used sum in the previous lecture, because this is quite similar to that. It's just doing it for this table right here. Okay, so now let's go ahead and jump to PgAdmin to walk through the solution. All right, here I am in PgAdmin. What I'm going to do is just to show what we actually have to work with here. If we select everything from the film table, the column that I'm interested in is the rating column. And so I'm just actually interested in R, PG-13, and PG. So we can say select, and let's start setting up our first sum. So the first sum is going to be the case. And there's different ways you can do this. We'll go ahead and do a case expression since we're just comparing the rating column to a bunch of separate values. So we'll say case rating when R then 1, else 0, end. Okay, so we're going to take the sum of that, and we're going to select this as, and let's go ahead and just select this as the R column. Now let's run this and make sure this works so far for the R rating. Okay, so it looks like that counted 195 instances of an R rating because I'm putting a 1 whenever there's an R. Now what I can do is simply copy and paste this 2 more times. So put a comma here to insert what is essentially a new column. And this one, instead of R, is going to say PG. And let's have that as PG. And now when we run this, notice I've added in PG. Let's put a comma here, paste this in 1 more time, and then we'll do it for PG 13, and we'll label that as the column PG 13. So when I finally run this, I get to see R, PG, and PG 13. So again, all I'm doing here is I'm saying case rating when it happens to be equal to the string, then a 1, else 0, end, and then I sum the results of that column, so a bunch of 1s and 0s, to get the final count of PG13. All right, thanks, and we'll see you at the next lecture. Welcome back, everyone, to this lecture on the COALESCE function. The COALESCE function accepts an unlimited number of arguments. It returns the first argument that is not null. If all arguments are null, then the COALESCE function will return null. So in practice, you simply have the COALESCE function, and then you provide in any number of arguments in order that you want them to be evaluated in. And typically these are going to be column names. And so to show you very simple examples, if you say select COALESCE 1 and 2, it's going to go along in order until it finds the first non-null value. In this case, it's simply 1, so it returns 1. However, if one of the values ends up being null first, such as select COALESCE null, 2, 3, then the first value is null, so it continues along. Finally, it finds a non-null value, which is 2, so it returns back 2. Now, of course, I'm sure by now you're wondering, when is this actually going to become useful? Well, the COALESCE function becomes useful when you're querying a table that contains null value, and perhaps you're trying to perform some sort of operation on it, which you can't actually perform with a null value. So, in case it's null, you want to substitute it with another value. I want to show you a really common example. So here we have a table of products. We have the item name ABC, the original price $100, $300, $200, and then a discount in dollars. So if the item has a discount off the price, it's listed in the discount column. So item A currently has a discount of $20. Item B does not have a discount right now, so it's null. And then item C has a discount of $10. So here we have a really common issue where we have a null value because something doesn't exist. So technically, item B does not have a discount, so it's a null value there. But if we're trying to perform mathematical operations, that is technically a discount of 0. So it's really common to use COALESCE to actually replace null values with a 0 for a calculation without having to affect or alter your original table. So let's imagine we're trying to answer the question, what is the final price? Which is going to be the price column minus the discount column. Well, we could try the following. We could say select the item column, comma, and then calculate, here in parentheses, price column minus discount column as final, so let's say as the final price, from table. Now unfortunately, that gets us this result. So we're able to correctly calculate the final price for items A and C, but since the discount was null for item B, SQL can't actually subtract null from an integer. So those are kind of incompatible data types. So instead, it relays back the information to you, essentially alerting you to the fact that one of the items was null by telling you that item B for final price is null. Now in this particular situation, we actually do not want the null value there. Instead, we want to know the correct discount. So this is where COALESCE comes into play. So since this doesn't work for item B, we want it to be 300, essentially 300 minus 0, we're going to use coalesce. And so this is where we can use coalesce in a clever fashion in order to fill in values for a null in case they pop up without having to affect the original table. So here we're going to say select item, comma, price minus, and instead of just subtracting the discount column, what we're going to do is say coalesce discount, comma, 0. So think about what's happening here logically. SQL is first going to check discount and check if it's a non-null value. So if it's non-null, meaning there's actually a number there, it's simply going to return back that number. So if there's a number for the discount, such as 10 or 20, it returns back that particular number. However, if discount is null, then it continues on to the next value, which in our case is 0. So it's super common just to have these two values in a coalesce function to basically say, hey, if this particular column happens to be null, go ahead and substitute in this next value, which in our case is 0. So now we no longer get a null value for item B. Instead, we get price minus 0, which is 300 for that particular row. Okay, so that's really where you're going to be seeing coalesce used a lot in the real world. So I want you to keep the coalesce function in mind in case you ever encounter a table of null values that you want to perform operations on. However, you don't want to actually go in and do any changes to the table itself, because it's often nice to understand that there's a null value there, essentially indicating that there currently is no discount on that product, for example, and not that in this particular case there's a 0 discount, because those can mean different things depending on the situation. So again, we have that useful function coalesce, which will come in handy if you ever want to do substitutions like that in the future. I'll see you at the next lecture. Welcome back, everyone, to this lecture on the cast operator and cast function. The cast operator lets you convert from one data type into another. So for example, you can convert a string into an integer. Now, the important thing to keep in mind here is that not every instance of a data type can be cast into any other data type. It must be reasonable to actually convert the data. Now, that term, what is reasonable, is usually pretty self-explanatory given the situation. So for example, if you have a string entry with the digit 5 and you want to cast that to an integer, that makes sense. It's quite obvious that that string 5 or that digit 5 will then be converted into the integer 5. However, if you have something more complex like the actual string spelling out 5, F-I-V-E, SQL is not going to be able to read that string, understand that English, and then convert it back to a digit integer. So as you practice more and more SQL, it should become pretty obvious what can be cast into what. But just keep that in mind. It must be reasonable to convert the data. And if you're thinking of using the cast function, you have already most likely done that calculation already in your head. So there are two main ways to actually perform a cast operation, and that is through the cast function, which is just general SQL syntax, and PostgreSQL has a specialized cast operator, which is just essentially a shorthand for a cast function call. Let's walk through first the original cast function call, the top one. Here we can see that we're simply saying select, and then within the cast function, what we're going to do is pass in the thing we want to convert or cast, then say as, and then the data type we want to cast that to. So here I'm saying cast that string 5 as an integer. The cast operator is essentially shorthand for this. Instead of having to write the cast function and the as keyword, since you're always going to be having to write that for a cast function, PostgreSQL itself has this specialized operator, which is just using 2 colons. So you're basically saying select and then the string 5 : to integer. Now keep in mind that typically you're not doing this on a single sample or single instance. Instead, you're going to be using this within a select query with a column name instead of a single instance. So for example, if you had a table that for some reason the date column was set up as a string entry, then what you can do is say select cast the date column there as timestamp from table. Let's go ahead and explore some examples in PgAdmin. All right, here I am inside of PgAdmin. let's first show you the actual syntax calls with single instances of casting before we run it on a column. So there's, again, two ways of doing this. I'm going to say select, and then I can call cast. And what I'm going to do here is attempt to cast the string 5 as the integer data type. And notice here that the highlighting within PgAdmin lets me know that I'm using the correct keywords. So I run this, and note now I get 5 back, but now it's an integer. And if I really wanted to, I could add in an alias call to call this new result column whatever I wanted, such as new int for new integer. Now, as I mentioned, it must be reasonable to actually cast this. So for some reason, you had the string 5 and you're trying to cast that as an integer. Let's go ahead and see what happens when we try to run this. Notice that PostgreSQL, if it's not able to do it, it's simply going to report back that you have an invalid input syntax. So if that happens to be the case, there's really nothing you can do as far as the cast function call. What you really need to be doing is making sure that either the thing you're trying to convert is reasonable, or if you had selected the correct data type. Now, as I previously mentioned, there's actually specialized PostgreSQL operators to essentially perform shorthand for this sort of conversion. Something to keep in mind is this is only available in the PostgreSQL engine. It's not available in a lot of other SQL engines. So what we're going to do here is basically remove that, say the string 5, colon, and then the data type we want to convert it to, such as integer. And note here, that's going to produce back the exact same result. So let's try it with another number, such as 10, run that again. And as I mentioned before, if you're doing something that doesn't make sense for SQL and you try to run that, it's simply going to report back an invalid input syntax. Okay, so finally, let's go ahead and explore an example use case of the cast function on a real table from our database. I'm going to select everything from the rental database, run that, and I can see here I have lots of different IDs like an inventory ID, customer ID, staff ID, and so on. Let's imagine for some reason I want to figure out the actual character length of the inventory ID, essentially asking the question, how many digits are within each inventory ID? So that's a little troublesome to do as an integer. There's no real way I can easily count the number of digits within this integer using mathematics. However, it's really easy to do with a string. I can simply ask for the character length of the string. And if I check out the documentation for string functions and operators, I know that there's a character length string right here. So character underscore length. So let's go ahead and try that out. What I'm going to do is I'm going to have to first cast this inventory ID as a variable character. So once it's a variable character, let's go ahead and run this, make sure that works. I can see that it looks the same, however, it's no longer an integer, it's character varying, which then means I can say, what's the character underscore length of this result, run that, and now it works. Notice now it's returning back an integer counting how many actual characters or digits were in each inventory ID. So that is a use case of why you may want to be using cast in order to convert data types, because you know that for certain data types, there's useful functions. If you try to just run this character length on inventory ID by itself and run that, note what happens. It's going to say that there's no function that matches the given name and argument type, essentially telling you you may need to add explicit typecast, which is exactly what we did earlier. Okay, that's it. I'll see you at the next lecture. Welcome back, everyone, to this lecture on the NULLIF function. The NULLIF function takes in just two inputs and returns null if both are equal. Otherwise, it returns the first argument passed. So the syntax we're going to be using is you say NULLIF and then pass in the two arguments. So for example, if you pass in 10 and 10 into the NULLIF function, since 10 is equal to 10, it's going to return null. However, if you were to pass in 10 and 12, Since those are not equal to each other, it's going to return 10. This becomes very useful in cases where a null value would cause an error or an unwanted result. Let's go ahead and show an example of this. So let's imagine we have this particular very simple table, and we want to calculate the ratio of people in department A to department B. So for example, we have the 3 entries, so Lauren, Vincent, and Claire, and their departments, so A, and B. And we can easily see here that the ratio of A to B is 2 to 1, or 200%. So we can actually use SQL to solve this with a case statement. So what we're going to do is we're going to jump to PgAdmin, quickly create this table, and then walk through solving that ratio. And then I'm going to edit this table slightly to show you why you may need a NULLIF statement. Okay, let's jump to PgAdmin and quickly create this table. All right, here I am in PgAdmin. The first thing I want to do is I want to make sure that I'm not editing an existing database like the DVD rental database. Instead, go ahead and create a database specifically for testing purposes. If you haven't done so already from previous lectures, go ahead and right-click on PostgreSQL and create a new database. You can call it whatever you want and then just hit save. So I've called mine Test Me, and it's for testing purposes. So here I have under Test Me, I'm going to right-click and then set up my query tool. So confirm that your query tool is connected to this test database by reading the tab here. Notice now, right here it says Test Me PostgreSQL. Okay, so now that I'm in this test database, let's create this simple table. We'll say create table, and let's call this table just DPTS for departments. And it's very simple, it just has 2 columns, which is the first name column. So let's say first name. And the first name, let's just make it a variable character up to 50, no constraints. And then the second one is going to be the actual department they're in. So that will also be variable character. Let's go ahead and say 50 and make sure we put a comma here so we don't get an error. So again, very simple table, just holds departments, same one we saw on the slides, a first name and a department letter. So we'll go ahead and run this, and that table has been created successfully. Now let's go ahead and insert into this table. So I can do that. Let me delete this create table. We'll say insert into departments, and I'm going to be inserting first name. No longer need that variable character. And I'm also going to be inserting department. And then after this insert command, recall that we have values, and then we say what values we're actually going to insert. So I want to insert the same ones, or roughly the same ones that I had in the slides. So let's go ahead and say, whoops, single quote here, Vinton, we'll have this person be in department A, comma, another entry here. We're going to have Lauren. This person is also in department A. And then finally, we'll have Claire, and this person is in department B. So pretty simple here. And then we're going to end it with semicolon just to clarify that's the end of our statement. So we're inserting into the departments table, first name and department, Vinton, Lauren, and Claire. Go ahead and run that. The insert should have returned successfully. If not, make sure you're checking for typos such as missing commas. And then what I want to do is confirm all this by selecting everything from this new departments table. Run that, and I can see here the results. I have Vinton, Lauren, and Claire. Okay, so as I mentioned, let's imagine that I wanted to calculate the ratio between male and female members. So the way I can do that is actually using a case statement. So what I'm going to do is I'm going to select, and this is where we're going to be doing a sum call. So I'm going to sum up the case when department is equal to A, then 1, else 0, and I'm just writing this kind of as a one-liner. So what is that doing? It's just going to essentially count up how many people are in department. So that should just create an extra column with 1s for the A's and then 0s for the B's. And then what I want to do is sum that up. So essentially, this is going to be equal to 2 since there's 2 A's. And then I'm going to take this. Let's go ahead and then make sure our parentheses are okay. So I'm going to take that result and I'm going to divide it by the sum of the case when department is equal to B, then 1, else 0, end. So what is this actually doing? This is basically, again, adding up all the A's. So this is going to be equal to 2. And then this is adding up all the B's equal to 1. And then we're going to take those two sums and then divide this sum using this division operator with this sum. Okay, so that should get me a 2-to-1 ratio, right? So then 2 divided by 1 should be equal to 2. And then what I'm going to do here is, after this, what I'm going to say is as, and let's call this the department ratio. So we'll say department underscore ratio. And I'm doing this all from this departments table. Okay, so again, doing those sums, dividing it to get the ratio as department ratio from departments. Go ahead and run this, and you should get back 2, since there was 2 A's to 1 B. So far, nothing too crazy, and we haven't actually used the NULLIF function yet. So what I'm going to do is now show you what happens if there actually are no more people in department B. Let's go ahead and say that person in department B left. So that means currently we have no person in department B. To do this, I'm going to delete this code. And don't worry, it's still available to us in our query history as long as we ran it. And then I'm going to type out delete from departments, and I'm just going to delete where department is equal to B. So run that, and notice that deleted 1 row. So let's go ahead and say select from departments, run this, and now I only have people from department A. So let's go ahead and see what happens if I try running that same ratio. So I'm going to go to my query history, and note here I have the select command, the delete command, and I have this select sum. So go ahead and copy this to your query editor, or you can retype it again if you wanted to, but I just copied from query history to our query editor. Run that same code again, and you'll notice that you get an error. This error makes sense because we are currently dividing by 0, which you cannot do. So how can we use the NULLIF functionality in order to make sure that instead of getting an error, we just get back a null? A null is a good indication that there essentially is no one in one of these departments, instead of having a full error, in which case it's not really clear what's happening. So what we're going to do is use the NULLIF around this second one right here in order to say return a null if there happens to be a 0 there. So the way I do that is recall that NULLIF is going to return a null if they both match. So that means if both arguments match both arguments I passed to NULLIF, then it returns a null. And right now I want to return a null if this entire sum happens to be 0. So what I'm going to do is pass in this entire sum call, go ahead and cut that and paste that, into NULLIF, and then the second parameter I'm passing into the NULLIF, and be careful of your parentheses here, is going to be 0. So what this is saying is if both of these happen to be equal to each other, meaning if the result of this sum is equal to 0, return a null. Otherwise, if these don't happen to be equal to each other, so this sum is actually returning something, then just return the first argument. So keep in mind, order does matter within this NULLIF function, because it's going to return the first one if they don't happen to be equal to each other. So now when I run this, instead of getting an error, it's going to return back a null. Because if you try to divide something by a null, then that simply returns a null instead of a division by 0 error. So a really common use case for a NULLIF is just to check against something, and specifically with the way databases are often designed, to check against something being equal to 0. And then if it happens to be equal to that, go ahead and return a null instead. Okay, so definitely take your time with this one. I know the code's a little bit complex here because we're using this case statement, but if you just take your time and read through the logic of what's happening here, it's pretty understandable that we're essentially just using NULLIF as a check against returning a 0. Okay, thanks, and I'll see you at the next lecture. Welcome everyone to this lecture on views. Often there are specific combinations of tables and conditions that you find yourself using over and over again for a project. So, instead of having to perform that same query again and again as a starting point and making sure all your statements are correct and having to rewrite that syntax manually, what you can do is you can create a view. That will allow you to quickly see the query with just a simple call as if it were a table that already existed. For example, let's imagine that you have a database and you're working on a project that has something to do with this database. And as you're working on this project and writing reports, you notice that there's two tables that you're always joining together. So you're always having to write this query of selecting these columns from these tables joined with each other and so on. Now, instead of having to rewrite that same query over and over again, what you can do is you can transform that into a view. That way, you can instead just say select everything from the view and begin working from there. So what a view is, it's a database object that is essentially just a stored query. And a view can be accessed as a virtual table in PostgreSQL. And the reason I call it a virtual table is that the view is not actually storing that data physically in another part. Instead, it's simply storing the query in a way that allows you to easily execute that query as if you were just selecting from an already existing table. So it essentially transforms a complex query that if you're going to use it over and over again, just call it as if it was some table. So we'll select it from the view. Okay. So another important thing to note is that you can also update and alter existing views. Let's explore these views in PgAdmin. Okay, here I am in PgAdmin. I've created a new query editor and I've made sure to connect it to my DVD rental database since I'm going to be using tables from the DVD rental database. Let's imagine we're doing a project within our DVD rental store where we need to constantly be asking information about the customer names and their addresses. Well, in that case, I know if I select all the information from my customer table, I can see I have a first name and last name. And if I keep scrolling down, there's an address ID, which corresponds to their entry in the address table, which if I search for this, notice there's an address ID here and an address. So let's go ahead and join these together. So I'm going to say, select the first name, last name, and address from, and then we're going to select this from, let's go ahead and select it from the customer table, inner join, address on, and we'll say customer dot address ID is equal to, whoops, make sure we spell address correctly, and then we'll say address dot address ID. So if we go ahead and run this, notice now we have the first name, the last name, and address. So notice that this sort of query can start to get complicated very quickly. So it might be useful to save or store this query as a view instead of having to write this over and over again. And luckily for us, creating a view is super simple in PostgreSQL. The way we do this is once you have the query that you want to store ready, all you're going to do is use the keyword create view and then decide what you actually want to call this view. So we can call this something like customer info, and we'll save that as, and then the query below. So it's just create view, the name of your view, as, and then whatever you were interested in. So we go ahead and run this. You should see create view is successfully returned, which means now, instead of having to rewrite this entire query, I can simply say, select everything from, and the new view we created, customer info, run that, and returns back the same output. Keep in mind, you're not duplicating any information internally. Instead, you're really just saving the query, and it will be automatically called for you. That way, you can expand on this by adding things like where calls or having statements or group bys and so on. Really helps you simplify things for complex queries. Now, if you find yourself needing to alter a view and basically change the underlying query information from it, that's actually also pretty easy to do. You simply call the create or replace command. So the way we do that is let's go ahead and say create or replace view customer info as, and then I'm going to go into my query history, and let's scroll down here, and in your query history it's going to be a little different than mine, but you should be able to find the original query we created. So I copied it. Let's go ahead and put it in here. So recall, here's our original view query. Let's add in a new column. Let's go ahead and add in district here. So what that's going to do is say select first name, last name, address, and then I want to add in the district column to my customer info view. So I'm going to run this now. And now it said create view, query returned successfully. So let's say select everything from customer info again. We'll say select everything from customer info, run that again, and now notice the district is also included there. If you ever want to remove a PostgreSQL view, what you can do is just like dropping a table, you'll say drop view and then the view itself. Just like a table, you can also check if it exists first to prevent errors. So you can say drop view if exists, customer info. Okay, if you ever find yourself wanting to change the name of a view, you can say alter view, the name of your view, and then say rename to, and then the new name. So we can say something like, let's say C_info, run that has alter the view, which means customer info is no longer available for me. So if I try saying select everything from customer info, run that, it'll say it won't exist. But if I say select everything from C info, run that, now it does exist. And if I ever want to drop this, then I can say just drop view, C info, run that, and now the view no longer exists. Okay, so that's the very basics of creating views for your convenience in PostgreSQL. I'll see you at the next lecture. Welcome back everyone to this lecture on importing and exporting data. In this lecture, we're going to be exploring the import-export functionality of PgAdmin, which allows us to import data from a .csv file or text file to an already existing table. There are some really important notes to keep in mind, however, when you're using the import-export functionality. The first important note is to realize that not every outside data file will work. Variations in things like formatting, macros embedded in the file, data types, data misalignment, etc. may prevent the import command from reading the file. If the file is just not compatible to be worked with inside of SQL, you're just going to have to either edit your file or change your existing table to make sure it aligns correctly with your existing data file. If you want more details about compatible file types and examples online, they're available to you in the online documentation, which you can reach at postgresql.org/docs/12/SQL-copy. The copy command is what import uses internally when it's actually running the SQL code to import things through the PgAdmin graphical user interface. The next important note is that you must provide the 100% correct file path to your outside file. Otherwise, the import command will fail to find the file. This is really similar to when we're restoring files based off the .tar file. If you do not provide the correct location, PgAdmin will fail to find the file. So I always ask you to confirm the file location underneath the Files Properties tab, and we'll show you how to do that in this lecture. And the most important note, the import command does not create a table for you. This is probably the biggest misconception among beginners with PostgreSQL and trying to create a table from a CSV file or from an Excel file. It is actually not possible to use basic PostgreSQL commands in order to immediately create a table from a .csv file or Excel file. The copy command for PostgreSQL and the import functionality for PgAdmin work under the assumption that the table is already created. There is currently no automated way within standard PgAdmin or standard PostgreSQL to create a table directly from a .csv file. Now, if that being said, I have posted a couple of external links to this lecture that may help you explore different methods of trying to create a function that will automatically create a table based off the header names of a .csv file. So you're essentially splitting it up now into two parts. In this lecture, we're going to create the table manually, But as you can imagine, there's a couple of tools that people have built to try to automate that process. However, these tools are not part of standard PgAdmin or standard PostgreSQL. So instead, we've posted them as external links, since as PgAdmin changes and as PostgreSQL goes through various versions, they may break their functionality at a certain point. So we're going to show you stuff here that we know will always work, regardless of what version of SQL or PgAdmin you're using. Okay, so now let's go ahead and work through an example through PgAdmin. Okay, here I am in my browser. I'm right now inside PgAdmin, but what I'm also going to do is I'm going to go to Google Drive, and I'm going to create a very simple CSV file underneath this spreadsheet application. You can really use any spreadsheet application here that can export to a .csv. So what I'm going to do is just call this simple underscore table. And what this is going to do is I'm going to have two columns, an A column and a B column. Let's go ahead and give it 3, why not? A, B, C, and then let's put in some values here. So 1, 2, 3, say 4, 5, 6, and then 7, 8, 9. Okay, super simple table. Then what I'm going to do is I'm just going to save this onto my computer. So I'm going to download this as a .csv file. So comma separated values. If you have an Excel file open, what you can do is you can save it as a .csv file. Okay, so I'm going to download this as a .csv file, and now it's going to be available for me underneath my downloads folder. So what I'm going to do is just to make sure and confirm I know exactly where this is, let's show it inside the downloads folder. And if I bring in my downloads folder, so right now I have downloads, my downloads, simple table. What I'm going to do is just rename this so that it doesn't have any spacing. And I'm just going to rename this, let's say simple table.csv. So there's no spacing within that .csv file. And what I also want to do is I want to confirm its actual location. Keep in mind, I won't be able to know where your .csv file is on your computer. So what I'm going to do is I'm going to confirm this by checking out the properties of this file. And I can see here the full file location. So this is extremely similar to what we did in the .tar file. And you can always just do a simple Google search for how to get the full file path if you're on a macOS computer or on a Linux computer or whatever your operating system is. So right now I'm on Windows, so I can just look up the properties to get the full location. So this is the information I'm going to be providing to PostgreSQL later on, along with the name of my file. So let's hit OK here, and I rename my file, I know its location, those steps are done. So what I'm going to do now is I'm going to come over here to PgAdmin. Let me close this little tab here. All right, so in PgAdmin, what I'm going to do is I have my test database that we've used in a couple of the lectures in this section of the course. I'm going to open up my query tool, and it's time for me to create a table. Now the table has to match up with the format of my .csv file exactly. So I have 3 columns, A, B, and C. So let's go ahead and create these. So I will say create table, simple, and there'll be 3 columns here, A, B, and C, and then let's have them be all integer data type. So integer, integer, and integer. Okay, there's no constraints, very simple table. As you can imagine, if you had a more complex CSV file, you could expand on this, add in constraints, and so on. So next what I'm going to do is I'm going to run this, and now that created my table. So it's time to actually copy the information that is within the CSV file and put it into this table. So how do we actually do this? Well, I'm going to show you that the table exists. So you should be able to now say select everything from simple, run that, and I have A, B, and C empty, there's no rows yet. Now the next step is to use PgAdmin's import-export functionality to actually grab the information from that external .csv file. So what I'm going to do here is the first thing, let's just quickly refresh our database to make sure that we have those changes within the simple table ready to go. And it should pretty much be confirmed because we were able to actually query that simple table. Expand the test.me database, and then go ahead and expand schemas, and then expand the public schema, And later on, you should see tables, and then the simple table we created, along with the corresponding columns A, B, and C. And so you can actually export the contents of any table as a .csv file or as a .text file. And then likewise, you can import information externally. So we right-click on the table itself, right-click on that simple table, and you should see something called Import Export. Go ahead and click on that, and this is the Import Export tool. So this allows us to actually either export information as a .csv file or .text file, or if I hit this little switch, now I can import information. Notice when I hit import, suddenly PgAdmin's asking me for a file name, which makes sense because I need to somehow provide the information of where to import from. So let me zoom out just a little bit so we can see everything that's happening here. Expand this again, right here. Okay, so it's time to get the file name. And the way I'm going to do that is we have two options. Just like for the DVD rental.tar file and the exercise.tar file restore, you can either manually type in the file, or you can hit these three dots and begin exploring your computer for where the actual files are. So if I hit here under My Downloads, I have simpletable.csv, and then I can select. You may need to show hidden files and folders, and you may need to play around with this format to show all files or CSV files or text files. If you have it as just CSV, then it should show you the .csv file we created earlier. So I'm going to select this. Now, if for some reason you hit those three dots and regardless of what options you're choosing, you still don't see your file, that's totally okay. You just provide the full file path manually. So you can always type in manually here what the full file path is. So that way, regardless of where the file is on your computer, you just pass in the full file path. Okay, want to make sure our format matches up. So that's CSV, so that's also correct. And now we have to go through a couple of options here. The first one is if we see the columns tab, it's going to report you the columns to import. And what's nice is you can remove these columns if they don't happen to be present in your table. So if for some reason you had an extra D column in your CSV file, you could just close that off or exit it and remove it, and then you wouldn't be copying that information into your table. Now, if we come back to options, what I'm going to do is I have to declare whether or not there's a header within the file. The header is just the first row that contains the column names, A, B, and C. That is present in our CSV file, and I don't want to duplicate information by having inserting the information of A, B, C. So I just say, yes, there's a header, and that lets PostgreSQL know, okay, I will ignore that first row. So I won't copy that over. Next, we have to choose the delimiter, so we can select from a list. So here I'm going to select comma, since it's a comma separated file. Then you can also specify the quoting character being used. So default is double quote, but if you have strings in your .csv file that are using single quotes, you can just go ahead and select single quote. In our case, it doesn't really matter since they were all integers. And then here we have escape, which if there's an escape value, essentially ignoring a particular character call, you can specify that through escape. For our very simple file, we don't need to worry about either of those. We'll go ahead and now hit OK. It'll say import export job created, and you should see now successfully completed. If you get some sort of error here, it's extremely likely that you provided the wrong file path. So triple check that you're providing the correct file path. Okay, so now that the copying of table data is done, what we're going to go ahead and do is rerun our select everything from simple. So now when I rerun this, notice I have successfully imported the data from that CSV file into my table here inside of PgAdmin. And to conclude this lecture, let's go ahead and show you how you can also run the export functionality, which is almost the exact same process. What you do is you decide on whatever table you want to export to a .csv file. Go ahead and right click on that, then select Import Export, and then we already by default have it on export. And you can decide what columns you want to actually copy over or export. Maybe you don't want all the columns exported. And then what you need to do is just basically where you actually want to save the file, you can provide a file name. So if I want it underneath my downloads, what I can do is I can copy this. Let me go ahead and click cancel there. I'm going to copy that in there, and then let's call this my new.csv. Essentially, I'm just going to provide the full file path of where I actually want to save this file and its name. And then after that, you can choose the delimiter you want to export with. So I'll export with a comma. And then if there's any string characters that you want to use quotes around, you can decide if you want double quotes or single quotes. Essentially the exact same things as we did before for importing. And you can also choose encoding if you need to. Then you'll just hit OK. And then that will export the file, which you should now see. If I bring over my downloads folder, I can see my new CSV has now been created along with the original simpletable.csv. Okay, so that's pretty much it for exporting. Exactly very similar to the import process. You just select export instead. Thanks, and I'll see you at the next lecture.